Hello.
Hello.
Yeah, can you guys hear me?
Hello. How are you?
Good, I'm doing well. How are you?
I'm fine. Welcome to DFS Marmara 2020 Turkey. So your name is
Chun-Heng.
Chun-Heng Tai.
My name is Chun-Heng.
Chan.
Yes. Yeah.
Okay, I would like to say it right actually. So if you're ready, you can. You shared already your presentation.
Yeah.
You can begin if you will.
Okay. Let me begin. Okay. Welcome everyone. Welcome to the Navigator 2.0 TED Talk. My name is Chun-Heng. I'm from the Flutter team in Google. So today I want to talk about the router, the new Navigator API and how to use it in a real application. So first thing, let's talk about the Navigator widgets. So Navigator widgets is a widget that maintains a stack of routes, and then it provides some API to modify the routes, but then it does not work efficiently if users try to use it in a more advanced use case. Let's look at all the difficulty that users may face when they use the Navigator widgets. First, it is imperative. The imperative means that instead of taking a list of routes to display on the content, it uses some imperative API such as navigator.push to push a new route, or navigator.pop to pop the current route off. So they provide this API to modify the route stack. But then this becomes an issue when users try to use a more complicated use case. For example, if users try to remove routes in the middle of a route stack, there's currently no way to do it. And then the second problem is user does not have the visibility to the route stack inside the navigator, because we think using the imperative API, the navigator owns the route stack. User can only modify it using the imperative API. So it does not make sense to expose the information to the user. And even if we do, there's no API to modify it. So we decide not to do it with the imperative API. The third issue is we don't have a good way to control the operating system event. For now, for example, if there's an Android back button event that will be fired from Android if the user press the back button on the Android device. Right now, there's no way to customize it. If user want to do something else, they need to apply the will pop scope widget on the right-hand side. It try to capture the pop on the root navigator, and then it delegate the pop to the other navigator they want. So this users usually need to do this if they have a multiple navigator. But then if they have more than 2 navigators, the structure will become really complicated. And it's not easy to write the will pop scope to work for more than 2 navigators. Lastly, the web application is a bit fragile. If you try to run the Flutter on web, multiple buttons in the browser will not work properly. So with those issues in mind, we want to introduce a new API to solve the issue. That is the Navigator 2.0. So let's take a look at what exactly is the Navigator 2.0. So Navigator 2.0 include 2 different API. One is called Page API. The other one is called Router API. Let's look at the Page API first. So Page API is a new decorated API we provide for the navigator. So the first thing that we introduce is the page class. So the page class is responsible to create a route that will be later on placed on the route stack. And then you will need to provide your own implementation of it. And to do that, you override the create route methods and return your own route that will be created using this page. Once you have those class, you can define your own list of pages. And with that list of pages, you can pass into the navigator.pages parameter. And once you do that, the navigator will update its route stack to match the page list you provide. If you want to update it in the future, you provide a different list, and the navigator will figure out how to update it. But then one important thing about this API is this is backward compatible. That means you can use the imperative API like push and pop along with the new page API. But then that brings us the one issue. What if user try to use navigator.pop to pop a page that you pass into navigator? So we provide a callback called onPop page callback in the navigator. In this callback will be called whenever the navigator try to pop a page that try to pop a route that corresponding to a page. So this callback give you a chance to update your page list to match what's actually on the route side in the navigator. So there's another API called transition delegate. This is the optional API, and then we provide a default if you don't provide your own transition delegate. So this delegate is used by the navigator when you try to update the page list. And then because navigator can figure out which page need to be removed from a route stack, and you can figure out which route will enter in the route stack, but it does not know how exactly does it remove or add it. Because to remove a route, you can use pop with the animation, or you can just remove, or you can complete without any animation. Similarly for the route that entering the route stack, it can be a push with animation, or it can just be an add without any animation. So this transition delegate class is designed to resolve that decision for the navigator. So if you want to provide your own transition delegate, you will need to override the resolve methods on the right-hand side. So in this method, you have all the information about the route that will be entering the route stack and the route will exit the route stack. In this method, you will want to mark those routes with appropriate transition or not. So once you have this class, you can pass into a navigator, and navigator will use it to resolve the conflict. So that concludes the page API. Let's now look at the router API. So the router API is a new widget that will wires up all the operating system event and then provide a way to override that or customize how you handle those events. So except for the router widgets, we also provide a new constructor on material app, as well as a Cupertino app and widget app that is called material app.router or Cupertino app.router or widget app.router. Because previously, if you use the material app, it will create a navigator for you by default. But now we want to use the router to replace the navigator. That's why we create a different constructor for each different material app, Cupertino app, and widgets app. So to use the router, you will need to provide different delegate that each delegate handles a different part of the operating system event and then wires up those events to build a navigator that will do the navigating. So the first delegate is called route information provider. So this delegate is a bridge that to send route information between the operating system and the router. The second delegate is route information parser. This delegate parses the route information that get from the route information provider, and then it will parse it into a result. That result will later be passed down the pipeline for further processing. The third delegate is called back button dispatcher. So this delegate specifically handles the Android back button, and this is an Android only thing because only Android has this intent. So remember, we talked about if users try to handle the back button, they need to write all the widget will pop scope and to capture different level of the pop event and then try to delegate to a different place, and it becomes really complicated if you have more than two navigator. So this delegate is designed to simple that up. So this delegate has its own structure that will decide which router, if you have multiple router in your widget tree, it will decide which router the back button will go to. And the last delegate is called router delegate. This is the centerpiece where it handles all the incoming operating systems events. this delegate also, it take care of the parse result from raw information parser. It also handles the pop event from back button dispatcher. And then it will also build the widget subtree for the router, which typically you want to build a navigator. So let's look at the program flow. On the left-hand side, you have operating system. In the middle, there's 4 block corresponding to 4 different delegates. On the right-hand side, you have a router widgets. So the router widget is basically a wrapper over all the 4 delegates and wires up all the arrow for them. Let's look at some flow. So start from the left-hand side, operating system sends the initial route event to the raw information provider. So raw information provider will hand that raw information to a raw information parser, and raw information parser will process it, and then it will call the set initial route on the router delegate and give the router delegate the result. And router delegate will then configure the app state. And then at some point, the router will then ask the router delegate to build a navigator for him. And then it will just build the navigator based on the configuration, based on the app state. And there's also another flow on the left-hand side at the top. The back button press, it will go to a back button dispatcher. And remember, this delegate will figure out which router this back button will go to if you have a multiple router. And once you figure out, it will call the pop route callback on the router delegate. And at that point, the router delegate will handle that by modifying the app state. And then at some point, the router will ask it to build a navigator for it. And lastly, there's another flow on the very bottom, all the way from the router back to the operating system. So this is for URL update for the web application. Because right now, your app will keep modifying app state to provide a different list of page to the navigator. So the router will constantly try to detect if there's any route changes. If there is, it will report all the way back to the engine, so that the web engine can update the URL and set up the browser history entry correctly. So let's look at each component. So start with the raw information provider. Raw information provider is a value listenable of raw information. So what exactly is the raw information? Raw information is a replica class over a string location and a state object. The location is formally the route name or URL in the Navigator 1.0. So there are the same thing. We change the name to remove confusion. And the state object is used in the web application that will be stored in the browser history, which we'll talk about a bit later. So as long as you provide the API for value listenable, you can use it to pass into your router. We also provide platform raw information provider, which is an OpenAD class that implements all the wiring between operating system and the raw information provider for you. So normally you just use that class and you don't need to provide your own implementation. Next up, let's look at raw information parser. So raw information parser parses the raw information into a configuration. So the first thing you want to do here is define your own configuration. On the right-hand side at the top, I define my own configuration as an enum that represents different routes just for simplicity. So once I have that, you need to keep in mind that this configuration class will be passing between raw information parser and router delegate. So when you design the class, you will need to think about how they will communicate with each other. So to override the raw information parser, you need to, sorry, I cannot read. So to override this class, you will need to override the parse raw information. And then for this example, I just checked the raw name in the raw information, and then I return a different enum accordingly. Sorry, return a different enum accordingly. And then this method returns a future because this is normally where you want to validate your URL. and then that typically involve DB call. Like you want to look up your database to make sure whether this URL is valid, and that typically is an asynchronous function. So that's why we make it asynchronous. And at the button side, there's also restore raw information. This is the reverse flow that we show in the previous diagram, and then this basically take the configuration from the router delegate, and then you want to restore a raw information. So in this example, I just do a switch case and return different location string based on that. Okay, next up, let's talk about router delegate. So router delegate, it handles different operating system events which involve the parse result from the raw information provider. Oh, sorry, the parse result from the raw information parser, and also the back button dispatcher, the pop event from the back button dispatcher. So to provide your own implementation, the first thing you want to do is you want to override the set new route pass, which on the right-hand side, several lines from the top. So in this callback, you want to operate, you take in the parse result from the raw information provider, and you should update your app state. Your app state can store above the router, or you can store in the router delegate. That's up to you. But for simplicity, I just store in the router delegate. So in this method, you update the configuration, and then you return a future of null. The second one is pop route, the one right beneath the set new route pass. So this callback will be called when the back button dispatcher dispatch the back button to this router. So in this method, you also update your app state, and then you return a decision, the future decision. If the decision is true, that means the router delegate, this router will handle this pop. If you return false, that will make the back button dispatcher to dispatch the back button to its parents. So if this is the root router, if this is the topmost router, and you return false, that means the parent will be the Android operating system. It will pop the entire app. And you also on the next one, you also have the current configuration getter. In this one, this will be called by the router when you try to figure out if there's any raw information change on the back arrow flow in the previous diagram. So in this example, I just return my configuration that's stored in the router delegate. And then the next step will be the build method on the very button. So this will be called by the router when you try to build its widget subtree. So in this build method, you want to build a navigator. It's not necessary, but in most cases, you want to build a navigator. And you want to use the page API here. And then you can construct your page list using your current configuration. And then once you do that, the navigator will just update its route set based on the page list you pass in. And since we use page API, we also need to provide on pop page callback. And in the callback, I just update the configuration when the route is popped. So one thing is also we provide a mixing, just try to make things simpler. It's called pop navigator router delegate mixing. I will show you how to use it in the demo later. So last, we have a back button dispatcher. So back button dispatcher will decide which router the back button will go to. And then usually you don't provide your own implementation because the framework provide the root back button dispatcher and the child back button dispatcher. Usually you will want to use this if you have a nested router, and then you want to decide which the Android back button will pop which router. And then to do that, normally you want to use a child back button dispatcher. So on the right-hand side, I show you an example on how to use it. Let's say in your widget state, you try to build a router, and then you want to delegate the back button to that router. The way you do it is in the change dependency. create your own back button dispatcher by calling the parent router. And once you create that, in your build methods, you will take priority on that back button dispatcher. The take priority basically notify the parent, says, hey, any back button intent comes to me. So once you call that method, you pass into a router, the router will now have the priority to handle the back button. So before we dive into the demo, I want to talk about web application for a little bit. So there's a backward flow that come from a router that report all the raw information back to the operating system, but we never talk about how exactly this web handles this information. Also, there's also a state object that in the raw information that we didn't talk about in the previous slides. So to explain that, we need to talk about the browser navigation first. First, this is not specific for Flutter. This is for web application in general. So the browser keeps a browser history, and then in the history, it stores a list of entries. So it also has a pointer to what the current page is on. So the browser will check whether there's entry before or after that to decide if there will be a forward or backward button. So in this case, if user push the forward button, it points the pointer to the next entry, and then it retrieves the URL and then the state associated with it and send that to the application to update. So in Navigator 2.0, we leverage the same browser history entry, and then instead for each entry, we store the raw information so that the browser forward and backward button will work naively. So how exactly do you write a Flutter, a web application using a router? So the first thing you want to do is you want to implement all the raw URL update method, namely the router delegate.get configuration getter, and the raw information parser restore raw information. And also you want to use the platform raw information provider, which will then report the raw information back to the engine. And the browser will create entry whenever it receives a URL changes. And then if you don't want that, if you want to change the default, you want to use a router.navigate, which will always create an entry even if the URL does not change. This is useful when you try to do an in-page navigation where the back button and forward button will change the state in this page without changing the URL. In that case, you want to use the navigate to force the browser history to create browser history entry. Or you can use router.neglect. This is the opposite of the navigate. This will force the browser to not create an entry even if the URL changes. And finally, all the browser navigation, whenever user press the forward and backward button, it will get the raw information and send that raw information through the router delegate.setNewRaw. So once you implement all the methods, the browser navigation will work out of the box. Okay, let's look at the demo. So the source code of the demo can be found in the URL. If you want to play around, feel free to clone it and play around locally. So let me show you some example. So in this demo, I want to, let me put it bigger. I want to rewrite an existing app that uses the old navigator to use a new router API. So in this app, first thing, it uses the routes API in the material app, and then for different route name, it builds different widgets. And for different widgets, for the home widgets, it just built a button that when you press, it push a new route. And in the tab page, it's just a tab view. So let's look at how this application runs. So here, this is the home page, and then you press it, you go to a second page, and then you can click the back button, which will pop the topmost page. Okay, so let's see how we convert this into a router using router API. The first thing I do is I convert my app into a stateful widget so that this widget now has a state that is on a router delegate, and then I convert my material app to use material app.router, and then in this API I pass in my route information parser and router delegate. So how do I implement this two class? The first thing you want to do is define your own configuration. Since in the previous app, we handle two routes. One is a slash, one is /tab. So I create my enum just to represent this two route for simplicity. And then I run my route information parser. In the method parse route information, this will take the route information, which will come from the operating system, and then I check the string location. If it is a slash, I return the enum home. If it's a tab, I return enum tab. Otherwise, I just throw an error. And remember, we also want to implement the restore route information method, which convert the configuration back to route information. In this case, I keep it simple. I do a switch case on the configuration. If the enum value is home, I return slash. Otherwise, I return tab. So that's for the route information parser. Let's look at router delegate. So here, I'm mixing change notifier and pop navigator router delegate mixing. So if you use this mixing, you don't need to worry about pop route from the back button dispatcher, because this mixing will wires it directly up to your navigator you created. In order to use this mixing, you will need to override your global key navigator global key getter. And once you have that, I also choose to store the configuration just inside the router delegate and create a getter setter combo. And then remember to notify the listener, which the listener is typically the router, whenever the value changes. And in the set new route pass, I just directly assign that to the configuration I store in router delegate. And get current configuration getter. This is for the backward flow that I show in the diagram. So for this one, I just return whatever stored in my current configuration. And lastly, I build my navigator. And then one thing, if you use pop navigator callback mixing, you will need to assign the navigator key to the navigator you created so that the mixing will be able to link the pop route callback to this navigator. And I use the page API, and then I create my page based on the configuration that's stored in the router delegate. I always create a home page. So here you notice I use material page. So this is a page class we provide for you to use. So this class take a key and also a child, which is a widget, and it will create a material page route that with the children you give in. So it's just a more simple API than override the entire page class. And then if I detect my current configuration tab, I also create a page, a tab page. So that's for the router API. There's one more thing I need to change. In my page widgets, previously when it's unpressed, we call an imperative API to push the new routes. But in this case, I want to update my configuration in the router delegate to be a tab. So it will add the page when on the next build. So others stay the same. Let's look at how this runs. So this is the app that built with the router API. You can open the tab, and then you can go back and forth without any problem. But one thing that you got is the back button will actually go through all your navigation, send for forward button, and then you can go back like multiple page at once. So by just converting your app to a router, you get this for free. And there's another thing I want to talk about, which is my app router with state. So for example, if let's say you have this tab view and you want to you can switch different tab, but then you want the browser navigation to also remember all the steps you go through. This you can do it in two different ways. First, you can store this tab index as a query parameter in the route name, and then whenever you switch tab, you will change the query parameter. In other way, if you don't want that, you don't want the URLs to change. You want to create illusion that this backward and forward button is only navigating inside this page. Then you will need to use the route information.state objects to store it. So in order to do that, the first thing I need to do is I update my configuration to also store a tab integer, which will corresponding to which tab the tab page is on. So once I have that, I modify my parse route information methods. It still checks for the route name, but it also pass the route information.state into my configuration, because right now the tab index will be stored in the route information.state. In the restore route information methods, I not only set the string route name, I also set the configuration my tab state into the route information.state objects. In the router delegate, previously I just stored the route enum. Right now I store a route enum and also the tab which the tab index. And then in set new router, I set the route enum as usual, but then I also store the tab from the configuration, and I give a default value 0, because it is possible the state may be null when you first launch the app. So I want to make sure I have a reasonable default for the tab index. And then get current configuration, I just create a new configuration based on my current enum and the state. And then the rest, and because right now the tab page will also the tab index coming from outside of the tab page. So I make tab page which is taking a tab index, and then that's on the tab page. I just make sure whatever I pass in, I will update my tab controller index. And then there's also another stuff, because right now the tab index in the tab controller need to be in sync with whatever stored in the router delegate. So I add a listener in the tab controller. Whenever the tab changes, I set the router delegate I update the tab in the router delegate. And remember, we talked about before, it only creates a browser history entry whenever the URL changes. So I need to use the navigate to force it to create an entry, even if the URL does not change. And that's all the change you need to make this happen. So let's look at how this runs. So you can open tab as usual, and then you can go between different tabs several times. And the cool stuff is now you can use the back button to go between tab without changing URL. And you can go forward too. So yeah, that's what I want to show in my demo. And that is actually the end of my presentation. Thank you for joining this TED Talk.
Hi, Chun.
Hi.
It was great listening Flutter from you. So thank you for being here today. It was great. Thank you. Enjoy your day.
You too. Thank you. Bye-bye.
Bye.